thank you so much for the introduction, and it's a pleasure and an honor to be here tonight. And we will be talking to you about something that you've probably not seen at these talks. Unlike some of the other talks that talk about volcanoes and bears and Alaska things, we'll be talking about information security, which might be a different thing, and maybe you think it's not as relevant. But as we'll see in what we present here, it's something that is increasingly relevant for all of us. And we'll have some good news and some not so good news. Kenrick and I started doing this research years back, and we were looking at the problem of shoulder surfing. If you're not quite familiar with what this is, when you're taking money from a bank, from an ATM, the advice is to make sure there's nobody behind you that can read your PIN as you're entering. The speaker before us, talking from the Arctic Supercomputer Center, was talking about sharing passwords, and sometimes people do that, but you certainly wouldn't want somebody, a stranger behind you, to share your PIN and get access to your bank account. Incidentally, years back, one of my very good friends was on a trip to Germany, and on the way to the airport decided he was going to stop at the bank and take some money out of his account, and his balance was $14. Turns out he thought he had 4,000. What had happened is somebody had gotten a hold of his PIN and somehow was able to manufacture an ATM card and use that PIN and emptied the account. The reason why $14 were still left in the account was you could only take money out in multiples of $20. So 14 was too small. The person who was taking money out had to leave them in there. As we were thinking about this issue of shoulder surfing, one day I suggested to Kenrick, it might be interesting if we could have something that would be able to look at the person's eyes and know what you're looking at. And this way you could key in things on the bank terminal with your eyes maybe, and nobody around you would be able to know what you're keying in. Sure enough, Kenrick went online and said, well, the technology's there, and that technology is eye tracking, and that's what we'll be talking to you tonight. Just to not to think that we're the only ones doing research on this, there's some other approaches there to protect people from seeing what you're typing, and we decided we were not going to go that way. We're going to go a little bit more high-tech. Just to give you a preview of what we'll be talking about, one of the first ideas was to have an on-screen keyboard and an eye tracker, which is this little device here, and I'll talk more about eye trackers later on. And what you see up there is a string of points that somebody looked at on the computer screen. In this case, the password that the person is trying to enter is zombies Q, and we just picked a wacky password because it had keys all over the keyboard. But what you see here is the way the person was looking at the screen. If you were sitting behind this person, you wouldn't be able to tell what the person looked at. That purple line there is what we drew on the computer to show you what the person was looking at. But again, if I'm looking at my computer here, you wouldn't be able to tell what keys I'm looking at. So that's one of the ideas about using eye tracking for information security. What we want to do today is give you a little bit of information on eye tracking, where this started, talk about some of the current applications, and you'll see some of them are in information security, some of them are in very different fields. We'll be talking about information security, including the shoulder surfing, but some of the other more interesting and more challenging applications, and then talk very briefly about the future. Eye tracking started way, way back. It's kind of unclear sometimes what the earliest approaches were. What you see up here in this picture is a person with electrodes attached to the skin around their eyes. And as you move your eyes around, obviously there are nerve connections that control your eyes, and those electrodes can tell a computer or a device attached where your eyes are moving, left or right. Another approach to know what the person is looking at is to use contact lenses that have a little coil embedded in them. You may imagine that's not something very comfortable, but if you have a contact lens with a coil embedded in it, as you're moving your eyes, that coil in the magnetic field can generate a signal that can tell a computer what you're looking at. On this other side here, you see one of the more modern eye trackers, although not quite modern, where there's a camera that's looking at the person's eyes, but as you can see, the person has to essentially be mounted in a head mount so that there are no movements that would confuse the eye tracker. Down at the bottom, there's another eye tracker that is now held on the person's head. This allows somebody to walk around, maybe in a room like this, and the computer will be able to know if I'm looking at the person here or a person there. Well, that was years back, 30, 50 years ago. This is where eye trackers are today. What you see on the left side up here is apparently just a regular computer monitor. But integrated at the bottom of the computer monitor is a little camera, just a regular infrared camera, that is looking at the user and that can tell what the user's eyes are looking at. So from the point of view of the user, it looks just like a regular computer monitor. But the computer that's attached to that monitor can tell what the user is looking at. And we'll see how that is useful. The device here on the side is the same camera mounted now on a stand, so you can use it with a monitor if you were to put it underneath the monitor, or you can use it again for somebody who's looking at an audience, somebody who's looking at the projection screen, and again tell what the person is looking at. Finally, down here at the bottom, these are very lightweight glasses with actually no lenses included, but with a little camera, and you can wear these glasses on your head. There's nothing attached, even something like this. It's just a pair of lightweight glasses that you can wear around, and as you walk around and you look at things, the computer can record what you're looking at and record your eye gaze patterns, as you'll see. Here's now the device that we have here with us, and we have several of these devices, actually different types of devices at UAA. It's essentially an infrared camera, and it has two LEDs. The LEDs would be here on the sides. And what these LEDs do is they create a reflection of the eye. So what you see down here at the bottom is a human eye. The dark side is the pupil. The slightly lighter area around it is the iris, and we'll talk about irises later on. And these two little lights that you see here are the reflections of the LEDs on the eye. Based on the relative position of those two reflections on the pupil, the computer can crunch some numbers and decide which direction the eye is looking at. So it's a pretty simple device. Here's what you can do with it. If you have a number of people, well, let me start with this thing here. If you have one person looking at the results of a Google search, which again is a page shown down here, what the eye tracker will show is the sequence of points that people fixate while looking at that website. And the way the human vision works is a series of fixations. So points where I'm looking at something and then moving and looking at something else, and the transitions from one fixation to another, it's called a saccade or a saccade. And the way the human brain works is the eye can get an image when I'm fixating something, and then when I'm moving my eyes somewhere else, the brain blanks out the vision so that we don't get the blur, and somehow we get a nice continuous movie of us fixating different points. Well, what you see on the website is that this person started at number 1 here, and then moved her eyes down to number 2, number 3, number 4, 5. So you can see that the eyes are darting around the website, the web page, and the eye tracker will record the amount of time each fixation took. If you have a number of people that look at the website and you aggregate the results, you can get what's called a heat map. And that's shown down up here, where the warmer colors, red and orange and yellow, are indicating that people spend more time fixating those areas. So obviously the red areas are going to be the ones that are more interesting because people spend time looking at them. The blue areas are maybe not so interesting. And then the black areas here on the side, obviously there's nothing to see, so people don't really look at those. A very similar picture is shown down at the bottom, except now instead of colors, they show a 3D graph, and the higher the peak, the more interesting, the more time people spent looking at those areas. So these are some of the things that eye trackers can provide in terms of data. One of the earliest applications, this is something in a paper from 1987, where people were shown this picture here, and researchers noticed that the way people looked at the picture depended on the task they had to accomplish. So you still see the picture in the upper left corner, but now here's the way people looked at that picture if they were told, just look at it. If they were asked to estimate the material circumstances, whether these were wealthy people or not so wealthy people in the picture, if they were asked to look at the ages of the people, if they were trying to anticipate or to decide what the family was doing before, can you see that each scan path is a little bit different? So the type of information that we're trying to get from a picture will dictate the way we look at the picture, right? Obviously, if we're looking at ages, we're going to look at faces. If we're looking at maybe wealth, we're going to look at the furnishings in the room, at what people are wearing, and so on. So again, this is something that's almost 40 years, 30 years ago. Here are some of the current applications. Advertising, we see a lot of it, and people have money invested in various ads. Well, if you were to look at these two, who here thinks that the one on the left, on this side, would be a better ad? Any thoughts on that? Okay. Who here thinks that the one on the right would be a better ad? Okay. We have some people who are undecided, but if you were to show these to an audience and use an eye tracker, here's what you'd obtain. And again, red are areas where people are looking more, green less so, and then everything else are areas that people are not looking at. As you can see, the ad on the left, our eye is drawn to look at the face, in particular at the eyes. The ad on the right here, we look at the eye of the person in the ad, but then we follow the gaze and we look at the product. And obviously, if somebody's paying for an ad, they want us to look at their product, and so the ad on the right is actually the better one. Okay? If we're looking at the website, same thing. Some people are paying for ads. Some people might be putting a website and trying to convey information. The way people look at the website will indicate how well that information gets communicated. And in web design, people talk about what's commonly known as the Eff pattern. You might spot an F letter here, the vertical bar, horizontal bar, horizontal bar. Here, the F has maybe more horizontal bars, but we typically tend to look at the website starting in the upper left corner. We look at the title maybe, we scan down the page, and maybe somewhere down the middle of the page just to see what else is there. Interestingly enough, if there are ads on the page, the ads tend to be on the right side, and this is an experiment where people looked at the website with the eye tracker, and then after the fact, for the data processing, they circled the ads with that fluorescent green. So the borders here were not shown in the experiment, but as you can see, people looked at the website, but really didn't pay any attention to the ads. So all these ads here, all the banner ads, ads on the side, they were essentially ignored by people. So we know that's bad news for people who are paying for online ads. Here's another type of application of eye tracking, which is now in medicine. If you have a person who has ADHD, the way they look at the face like this is as shown on the right, whereas a person who does not have ADHD, a control subject, will tend to look at the eyes, look at the mouth in a more structured, in a more sort of predictable way, as opposed to this more scattered way. Okay? So one of the things that we're interested in, and we'll talk about later on, is how the way people look at things might help us identify not just whether those people suffer from certain diseases or not, but who they are. And we'll talk about that later on. At this point, I'm going to turn it over to Kendrick, who's going to talk about some other applications before we move on to information security.
All right. So this first application is with eye tracking. one of the questions early on was, well, how is it that people read? And here we can see these saccades that we were talking about earlier, and the red dots are the normal reading pattern. Someone's reading from left to right, and here we can see where the fixations have jumped from one place to another, and then back to the left. And so that's kind of the typical reading pattern that we'd see. We don't have an example up here, but for example, someone that is dyslexic tends to have some more backtracking in their reading patterns. So we can actually use eye trackers as some diagnostic tools, as also indicated from the previous slide. And then here's an example of what we'd see if someone's skimming through some text rather quickly. And so we get these fixations, fewer per line, as someone scans quickly through this text. So this was early on trying to figure out how is it that people are processing text and reading. And we think the next way we go is if we have a computer that knows how someone's reading, how could we actually adapt the text to match the current mode of the person? So for example, if someone is skimming and we have an eye tracker that can tell that someone's skimming because they're using these big jumps from word to word, then we could do something like actually change the text to highlight perhaps the key word so it actually helps the person skim more easily. Another simple example, if someone is reading and we know where they are, then if they stop reading and come back later, we've got like an automatic bookmark, and so we can instantly go back to where they last read. And then another example, if someone is, say, hovering, if someone's looking at this word processing longer than normal, then we can do some other things like, if this is not your your native language, then we might pop up the definition, for example, or speak the word, and so we can have kind of these active books that can use eye tracking to adapt to what the user is doing. Another example, lastly here, is this is like a children's book, for example. If someone has just read this paragraph, then we could actually have maybe a little animation in the corner that depicts the scene that they just read. And so we think there are lots of ways we could go with eye tracking being integrated into a really more active experience. So here's one area where we can use eye tracking. Another place where eye tracking has been used is with cognitive studies, for example, developmental psychology. And if we've got some kind of study, say, involving infants, then you can't just ask the infant, what do you think about this? They can't really answer. But if we can see what the infant's looking at, then the eyes really kind of give away what's going on inside their brain. The eyes are kind of like a little window into what someone is thinking. And here's an example from the University of Rochester's Baby Lab, where they were interested in the question, what age is it that a child can have like a representation of an object and hold on to that representation in their brains? And here's a little video, and in this little demo, we've got this ball that goes behind this obstacle, and if the infant is able to track the ball and have a representation of it, then when it goes behind this obstacle, then they would expect it to pop out on the other side, and their gaze would go there, and with the eye tracker we can actually tell if they've made a representation for the ball. And so if you look carefully, that little blue dot did briefly zap right over here, and so the baby did expect the ball to come out on the other side, indicating that they can track and have a representation of it. And so from this we know that as early as 4 months old, someone is able to build these representations. Another research area where eye tracking has been used that does tie into our security theme is for homeland security. And so this is purely a research project. There's no actual device like this that's put into practice anyway. And this is a project from the University of Arizona. They built something called the Avatar Kiosk. And the idea is you'd be at an airport going through the airport screening, and you can't really see it too well here, but there's a little face there. So there's an avatar on the screen that would ask you these screening questions. And there's an eye tracker built into this. And one of the things that the eye tracker can do, in addition to telling what you're looking at on the screen, is an eye tracker can also measure your pupil diameter. And if someone is a little anxious, then our pupil actually dilates to let in some more light. And so the pupil diameter is kind of, you can use it like a lie detector to see if someone is perhaps telling the truth. And so here, if we ask these security questions, do you have any weapons on you? And if the pupil dilates, then that's a sign that maybe the person's not being truthful and might be, brought in for more questions. And then here's another related idea with this device. Over here on the right is a picture of a pipe bomb. And if you were someone that knew about pipe bombs, then you might know that, well, over here is some kind of triggering device and the timer, and inside would be the explosives. And what we could do is if someone is a potential traveler and we show them this picture where it's got this thing over here has been removed, then if you know about pipe bombs and this particular kind of device, then you'd be looking over here. You can't help but look over here and notice that something is missing from this device. But if you knew nothing about these kinds of devices, then you would just be looking at other places that probably over here where there's something actually more interesting to look at. And so the gaze of the person is a little bit of a tell to indicate what they may or may not know about these kinds of devices. So there's another possible application for this kind of technology. And we haven't mentioned assistive technology yet, but that was one of the first applications of eye tracking. And so if you're disabled and you can't move, for example, then we can use the eye tracker like a mouse. And the way this would normally work is where you'd be looking at on the screen is where the mouse would go. And then if you blink or if you stare at something for maybe a second or so, then that turns into a click. There's been the hope that we can use these in cases for someone that's not disabled. And it's a little bit trickier than it sounds. At first glance, it sounds great. I can look at this place and then I can click there and I don't have to move my hands or anything. But the problem is, we look at all sorts of places and we don't really mean to click there. And so sometimes we have these errant clicks that we didn't intend. So that's called the Midas touch effect. So people are still working on ways to address that. Another place where eye tracking has been used is with usability studies. And so in general, if you have any device or piece of software and you want to figure out, can people really use this thing? Then we can use eye tracking to get a better handle on how people think the device should be used. Here's an example of an Android keyboard on the phone. And if you think back to some earlier smartphones, some of the keyboards really were not that great. Actually, with my current phone, I have a phone with a physical keyboard, and there's no tilde key, a little squiggle. And for over a year, I just figured it doesn't have the key. And then finally, I stumbled across if I hit these two keys in the sequence, then a little on-screen keyboard comes up, and I can actually select that tilde key. And so the question becomes, well, do people really know how to use the keyboard? And we can do these studies to figure out what people do. And so, for example, you might give someone the task of type in this particular sequence of letters, and then you watch as the person tries to do it. In this case, we can see where the person is touching, and then the red dot is where the person is looking at that point in time. And so if we had given someone the task of typing in something with a tilde, then we could look and see, well, where are they trying to find the tilde on the keyboard? And if they can't find it, then maybe we can rearrange things to put the tilde in some place where the people are actually looking for that. And then we've been doing some work with eye tracking for education. And there are some nice possibilities here for any kind of scenario where it might be helpful for the instructor to know what is it that the student is looking at. And one example is reading comprehension. Another one is speed reading. And so in speed reading, there's a particular pattern that the student should be doing as they're reading through some text. And how does an instructor know if the student is actually looking in the pattern that they're supposed to? Another example is air traffic control. So air traffic controllers have another particular scan pattern as they look at their displays. And so what we set up is a system where over here is a student that would be using some application, for example, looking at some simulated air traffic control on the computer screen, and it's got an eye tracker on it, and the student doesn't see any of these things like the red dots or anything like we've shown on the previous videos. So the student uses the application just like a normal application, but then we put this thing up to another screen where the instructor sees the same thing that the student sees, but then we overlay where the student is looking on that screen. So in real time, the instructor can see what the student's looking at as they're using the program. So as one example, we worked with a music teacher, and he teaches piano, and he was very interested in trying to figure out what are his piano students looking at on the sheet music as they play piano. And so here we have a little video of this. And so here's a student that's playing a little piano piece, and then this red highlight is what they're looking at. What can we tell from something like this? So for example, if he had a case where the student was spending too much time looking at the notes that correspond to their left hand, and so that should have been something they should have been able to just play from memory, and so that's something that the instructor could tell based upon the eye tracking patterns. And then the student should also be looking a little bit farther ahead from the notes that they're playing. And we can learn all these things if we had the eye tracking system as the student plays piano. And kind of going forward, one of the other scenarios of this would be if we had a completely automated system where a student's trying to learn piano without a human instructor, then we might be able to have a computer system that could tell, how the student's reading the notes, correlate that to how they're playing on the keys, and then better teach the students piano lessons. Okay, so I'm going to turn it back to Bogdan and talk about eye tracking security.
Okay, so just to recap, so far we've been talking about eye tracking in general. And we've seen applications in marketing, applications in medicine, applications in education, but our interest is mainly on information security. And what we'd like to do is see if we can use eye trackers to identify people. So basically to replace your password with something else that is more convenient. And again, the speaker before from the Arctic supercomputer was talking about how if somebody were to steal your password, well, that's a problem. If you're sharing password, well, that's another problem. At some point he was talking about the multiple factor authentication where you had to enter both a password and a PIN from this special device. So to be secure, at some point the system gets to be rather complicated and clumsy. And if you think about the way things work in security, there are two models out there. With your credit card, if you happen to lose it or somebody happens to steal it, well, nobody's too worried about that because industry standard is such that if you lose your credit card, the bank will have to take care of any money loss. On the other hand, the everything else model for computers and for pretty much anything else we own, if you lost it, well, it's your problem. So in that sense, what we'd like to do is make computer security a little bit more user-friendly so that people are not too worried. I was talking earlier about how when you make things secure, they get more complicated. And in information security, these are the two extreme points. You have one computer that's maybe out there in the public marketplace and anybody can use it and there's no password or no issue, then obviously that's very convenient because whenever you want to get access to that computer, just walk to it and you access it. On the other hand, you can't protect anything there. At the other extreme, you have the military super secret computers that are buried down underground and layers of protection. Those are obviously very secure, but the problem is they're not very convenient. So for most of us, we fall somewhere in between, where we might have a computer that's in a protected room, maybe has a password, but we want to have access to it. Your phone, right? If you have a password on it, you don't want it to be too long or too complicated because you want to get to use the phone quickly. So what we're talking about here is authentication. So proving to a computer that somebody's identity is what they say it is. And there are two ways to do this. One is verification, where the user claims I am Jane Doe, or I put in my username, and then I have to enter a password that verifies my claim. The other approach to authentication is what's called identification, where typically the FBI at the crime scene finds some fingerprints, and based on those fingerprints, they don't know who the owner of the fingerprints is. They have to go and search through the database and find the user who, or not the user, but the bad person who left the fingerprints behind. Okay? What we're trying to do with computers is typically the verification part. And to do authentication on computers, there are typically three things. Most familiar to people is the password, which is something secret that only you have. But also it can be something you have, which is a key, a special hardware token, sometimes a little USB key that you have to plug in, or something you are. And that's what the eye tracking can provide, which is in the general category of biometrics. Also, for very secure applications, people are combining some of these things. So your ATM card is both the card and a PIN associated with it. Those are two factors of authentication. What you see here are some of the most familiar biometrics: fingerprints, iris recognition, right? Face recognition. These are techniques that people use sometimes to identify users on computers. The two down here, palm vein recognition and retinal vein recognition, are a little bit more secure because the palm vein recognition, for example, is based on the heat emitted by the blood vessels in your palm. So if somebody were to just take a picture of my palm, well, they couldn't pass this sensor here. On the other hand, people have made rubber fingers, they've made gummy bear shaped, well, they've melted gummy bears and made them into fake fingerprints, and those are good enough to fool some of the fingerprint sensors. Same thing with iris recognition. You can take a picture, a high-resolution picture of somebody's eyes, and then put it in front of a sensor, and you can fool the sensor. So what we're interested in using the eye tracker is getting to some biometrics that may not be stolen or may not be counterfeit. There are some other biometrics like this that people are talking about. And what's shown here is a piece of a computer keyboard, because the way you type on a computer keyboard is uniquely enough to where, to some extent, the computer can recognize you just by the cadence by the sequence of how you type your password. The way you move your mouse is again unique enough to some extent that the computer can recognize people. Our heartbeat is unique enough to where a computer that would be able to sense that would be able to recognize the user based on heartbeat. Down here, people are talking about retrofitting chairs with sensors because the way we sit, the way we move, the way we fidget is unique enough to where computers might be able to recognize us just by the way we sit in chairs. Walking is also unique enough, and obviously that would not be something that's applicable for computers, but for somebody using a smartphone, if you've got your phone out and you're walking up and about, the phone would know that it's you because the way you walk is specific enough, and the phone has the sensors built in to recognize that. And then down here in the lower right corner, even the posture, if the phone has a camera, it could sense whether you're sitting up straight or slouching in a particular way, and again, recognize you based on that. So what we're doing is part of this biometrics category and trying to identify things that are behavioral in nature. So in other words, are things that we do, and I would not be able to imitate the way you're sitting or the way you're walking or the way somebody else is behaving at this level. And so if we build a composite picture of a person based on all these biometric characteristics, we might be able to recognize people and not require them to enter a password. So let's look at what an eye tracker can do to help us in that respect. We have a little video in here of using an eye tracker, not just to do the eye tracking, but to also do iris recognition at the same time. And I'm going to let this play.
Hi, my name is Kenrick Bach, and this is a short demo of Iris Gizmo. Iris Gizmo is a proof of concept program that demonstrates iris recognition using an eye tracker. Now, what you're looking at here is a screen capture of the computer monitor of the desktop, and attached to this computer below the monitor is an eye tracker, which is essentially a little camera that's able to determine what we're looking at on the screen. Now, in this application, we're not really interested in what the user is looking at. We're really interested in using the eye tracker to get reliable images of the user's iris, which we then use for user authentication. And in this screen here on the left, we have some information about the last user. Here's an image of the user's eye and some image processing. For example, here we can see the donut shape around the iris has been extracted from the eye. And then over here it's been unrolled into this rectangular shape. And from that, this becomes sort of like a fingerprint that we can use to identify a user. Now, the idea with Iris Gizmo is we can continuously do iris recognition of whoever's sitting in front of the computer. So I'm going to start this demonstration, and here Bogdan Hoanca is sitting down in front of the computer, and at this point, I'm pausing this video. At this point we can see that we've got these crosshairs in the eyes, and the eye tracker has zoomed in on the user's eyes. And shortly the software will attempt to extract the iris and do lookup to see who was sitting in front of the computer. Now, here we got an image of the iris, and we'll see down here that there wasn't a match. And in this case, the problem was the image we got had a little too much eyelid around it. But if we keep on going, the next snapshot we get is a much better view of the iris, and we're able to correctly identify the user that's sitting in front of the computer. And he's identified again. And now, when the user gets up and leaves, then normally, once you've logged in and left your computer running, then anyone else can come, sit down, and start using the computer. But imagine with software like this, we could detect when someone new is sitting in front of the computer and perhaps switch to their user profile, or not allow them to log in, or do a whole variety of other things. So if I continue this video, then in a moment, here I'm sitting down, and my irises are recognized, and here we have a match to myself using iris recognition with the help of an eye tracker to zoom in on the user's iris sitting in front of the computer screen.
So just to recap what we showed in the previous video, you have a user that comes to the computer, sits down, and without entering any password, because of their iris pattern, they're recognized by the computer. If they get up and leave, they don't have to worry about locking the computer. The eye tracker detects that the iris is not there anymore, and it'll lock the computer. Another user comes by, sits down at the computer, they're recognized as a different user, and the computer automatically switches into the other user mode. So we view this as a very nice and user-friendly way to authenticate, because again, this device is just sitting in front of the computer. And the user comes in, sits down at the computer, uses the computer, walks away. They don't have to worry about the password or any other way to authenticate. They are just recognized. Using the eye tracker to do iris recognition is a little bit challenging, because this is not the camera like the one built in a real iris recognition system. It's lower resolution, it's a little bit different wavelength. The user can move about, which is what the users typically do. And the eye tracker is relatively far from the user. In contrast with that, an iris recognition system is typically a device where you have to place your eye close to the camera, you have to be motionless for a while, and then you get the really good iris recognition. But on the other hand, using the eye tracker is convenient. If the user is using this to control the mouse, they are interested in being on camera because otherwise they're not going to be able to control the mouse. And overall, it's a very user-friendly experience, and it allows the iris recognition to happen continuously over time. So if you're using the computer for 2 hours, you could be confident that the person sitting in front of the computer whose iris is being recognized is the same person who sat down in the first place. We did a live study at UAA with 37 users. We did several approaches of recognizing users either more frequently or over longer periods of time, but with better accuracy. And here's what happens. We had a little bit of a different approach where we still use the password. The user would come in, would enter the password, and while they were entering the password, the system would take images of their eye and build a profile of the iris. Once the user was done entering the password, the user would go on and use the computer, do some Google searches and things like this, and in the meantime, the system would compare the original iris with the current images of the iris. So again, the user would not have to worry about entering the password or anything. I mean, they would do it once, but then the eye tracker would recognize them for however long they would be using the computer. So it would be a much more secure way of somebody interacting with the computer. Well, drum roll, or maybe not quite, how well did we do with this? We got a 9% error rate, so about 1 in 10 errors. For biometrics, that's actually very bad. You might think 1 in 10 is not too bad, but people want to be really, really sure that the real user is the real user. On the other hand, this is just because of the limitations of the current eye tracker. It's because of the limitations of the current algorithms, current computers. So we think something like this can get a lot better. Here's another way, which is further out in the future, and it's, we think, even more promising. Suppose you come to your computer and you sit down there and you just have this dot that moves on the screen. Well, with an eye tracker, you can actually record what the user looked at. And what you see here are two users, user 1 and user 2. The blue is the waveform that shows which way the red dot was moving in the two directions, in the X direction and the Y direction, so horizontally and vertically. And if you look at user 1 and user 2, you might notice that the red and the green, which are the way the eye was moving following that dot, those waveforms are a little bit different. So what we are working on is a way to recognize people by the way they can follow the red dot. You don't have to remember anything. There's no password to share. There's no password to forget. You just look at the red dot, and the computer can tell, are you looking at the red dot the way you would look or the way somebody over there would look at? Okay? So something like this, again, is very user-friendly because there's no password to forget. On the other hand, something like this is not something that you can use over time, just the way we do the iris recognition, except if you have this red dot appear periodically. What we see is the future of authentication on computers. If you have a password, you might use it, or maybe not. You could sit at the computer and be recognized based on your iris, based on the movements of your eyes. One thing that people are concerned about when we talk about iris recognition is if their iris pattern is going to be stored somewhere. But the way we use the eye tracker, we don't have to store the iris pattern more than just for the duration of the person using the computer. So it has some privacy protection as well. And as we showed you in the little video demo, automatically, once the user gets up and leaves the computer, they're recognized as not being there, and the computer locks up automatically. There are companies out there that are working on doing eye tracking on regular smartphones, since you have a camera already built in. There are companies, Lenovo, for example, is talking about having an eye tracker integrated into a laptop computer. People have used eye trackers, or they have used webcams in computers as eye trackers. And so an eye tracker might be coming to a computer near you. I don't know if I've convinced you that the eye tracker might be a good thing for authentication, but I wanted to say just a few words about privacy in the end, and talk about something else that's also interesting about eye tracking. Most people think about eye tracking and they wonder, well, the computer is going to know what I'm looking at on the computer screen. But in fact, with current technology, the people in the IT department would easily know what is on your computer screen, if that's what you're concerned of. Your internet service provider might know what is on your computer screen. So an eye tracker is not going to do much more in terms of privacy issues. But here's something that's a little bit more insidious. This is another old experiment with an eye tracker. And what you see on the left side are eye tracking data for a user that is a novice driver driving a car, and on the right side, an experienced driver, again driving a car. And what people have noticed is that the way novices, so beginner drivers, drive in a different way or look at things in a different way. We know they drive differently, but they look at things in a different way than experienced drivers. They've done this with air traffic controllers. If you've been an air traffic controller for a long time, you look at things very differently than if you're just getting started. If you're a computer programmer, right? You look at things, look at different things than if you're an experienced computer programmer. So in a number of fields, the way you look at things can tell the computer how proficient you are without having to answer multiple choice questions or things like this. So we think that maybe at some point in the future, it might be possible to identify people not just based on the eye patterns, not just based on the iris patterns, but if you think about it, the computer could show you a few things and quickly figure out, do you know how to fly an airplane? Do you know how to drive a car? Are you a good programmer? Without asking you questions, just by showing you some things and understanding what you look at things and how you look differently, whether you're proficient or not, at these very different areas of your life. So maybe authentication is going to be much less about passwords and much more about who we are in terms of a multifaceted personality and skill set and so on. And so we believe that authentication using eye tracking is going to be much more secure and much less of a hassle than it currently is. So in summary, we've talked about multi-factor authentication, some of the work we did. Kenrick shared some of the work we do on education research in music and speed reading and so on. We are currently looking for other faculty at UAA and at UAF, if anybody is here, interested in using eye tracking in their research. And at this point, we are open for questions.